Welcome to Introduction to SQL for Excel Users, Part 11, More CTEs and Windows. I am your instructor, Dave Langer. I'm particularly excited about this episode of the series because we're introducing RFM analysis in this video. And why it's so exciting is because now you've acquired enough SQL that you can do analyses directly in SQL and use the power of the database server to gain insights from your business data. And what's really cool is when you code up your analyses directly in SQL, you can leverage the power of the database server over millions of rows, or tens of millions of rows, or in some cases, hundreds of millions of rows of data. This is awesome stuff. Code up your analysis in SQL, you fire it off at the database server. Maybe you go grab a cup of coffee. When you come back, blammo whammo, a whole bunch of really useful insights come back to you. If you're not familiar with RFM analysis, it comes to us from the world of direct marketing. For example, snail mail circulars that you actually get in the physical post. That is the origin of RFM analysis. And it's an old school technique to be sure, but it is still commonly used and it can be quite valuable. So RFM is really, really simple. You use it primarily as a way of quantifying the quote unquote value of your customers. And usually you use three vectors, right? RFM, you have three vectors. R stands for recency. How recently has a customer made a purchase? Frequency, F. How often does a customer make a purchase? In M, monetary, how much does a customer spend on purchases? Now, if you think about it, this makes a lot of sense. If you wanted to quantify more valuable customers from less valuable customers, your most valuable customers would have bought recently, they would buy often, and they would buy a lot. And that's essentially what RFM analysis does. But this concept is wildly useful even beyond customer valuation. You can actually apply the idea to any number of scenarios. So for example, in a previous job, I used the RFM concept to analyze and rank US states for marketing purposes. And what I did essentially was I grabbed a bunch of data from the United States Census Bureau, which is part of the federal government in the US, which has freely available data that anybody can grab. And it has different kinds of characteristics based on zip codes and states and that sort of thing. And what I did was essentially just stack rank them. I took the data from the Census Bureau, used the RFM concept, and then stack rank them. And it was very useful. It was very enlightening to realize that certain US states were way better for us for marketing purposes than others. And even within those states themselves, certain US zip codes, certain US postal codes were better for us than others. So this thing is wildly, wildly useful. You can use it for all kinds of things. Conducting an RFM analysis is actually quite simple. So you grab a collection of your customers. Maybe it's all of your customers, maybe it's a certain segment of your customers, maybe from a particular region, who knows. But for each customer that you decide to analyze, you calculate the elapsed time since their most recent purchase. That's the R for each customer. 2, how often purchases are made. That's the F of the customer. And 3, the total amount spent, the M for each customer. Now, one of the things to consider before you do an RFM analysis is for steps 2 and 3, you can do different types of analyses based on timescales. So for example, you could be looking at customers across all time, or maybe just in the last year or the last quarter. Generally speaking, you typically want to have more recent timeframes rather than older timeframes, because obviously recency matters. That's part of the reason why it's the R in the RFM. So generally speaking, all time can be useful, but if you have a very mature company with customers that exist for long, long periods of time, that might not necessarily be the best thing. You might want to go for something like the last year, but it all depends on your situation. So once you've calculated these things, you then need to score them. So for each customer, you score 1 to 10 for each of the R, the F, or the M. And for the top 10% of, let's say, all of the customers' R scores, the top 10% of those get a 10. The next 10% get a 9, so on and so forth. So what that means is that for each customer, they get a 3-part score. They get a score from 1 to 10 for the R aspect, a score from 1 to 10 for the F aspect, and a score from 1 to 10 for the M aspect. And what that allows you to do is then stack rank your customers based on 10, 10, 10, which would be your best customers, and your worst customers are going to be 1, 1, 1. For example, a customer that is 1, 1, 1 is in the bottom 10% in terms of recency of purchases. They're in the bottom 10% of the frequency of purchases, and they're in the bottom 10% of the total amount spent. Now, obviously, if you're doing something expensive, let's say you're mailing catalogs in the post, big, beautiful, colorful catalogs, which are not cheap to print, one, and then two, they're not cheap to mail. You probably don't want to send an expensive catalog to your 1, 1, 1 customers, but you definitely want to send them to your 10, 10, 10 customers. This is the power of RFM. It allows you to stack rank customers based on their behavior patterns. Now notice this concept, once again, is based on these definitions of RFM, but the idea applies to anything that you might want to consider. In the aforementioned example that I used for US states, for example, I stack ranked areas based on the number of high income households. So if they were in the top 10% in terms of population of high household incomes, they got a 10. So that is also a good idea of how you can use RFM analysis, the concept of an RFM analysis beyond just what we're talking about today. That's enough of the background. I'm not going to have any Excel in this video. It's going to be all SQL. So I'm going to flip over to SSMS and let's get started on this RFM analysis. Here I am in SQL Server Management Studio. And for this particular video, for this particular analysis, we're going to switch tables. We're going to use fact internet sales, which makes some sense, right? Because generally speaking, RFM analysis is all about customer purchase behaviors. And this is a table in the AdventureWorks database that actually talks about what internet sales were made to which customers. This is a good table for us to use. And you can see here that there's quite a number of columns and a lot of these keys. But usually what ends up happening is that while this is useful, oftentimes actually looking at the data gives you more of an intuition of what's going on in the data within the table. So I'm just going to go ahead and make this a little bit bigger. And I've got a little query here that's going to pull back some records for a specific customer. Now I've picked this customer because their purchase history illustrates the nature of the data in this table very well. Okay, so I'm going to go ahead and run that. And you can see here we have the data for a particular customer, customer key 19766. This table stores sales orders that were made over the internet to customers, which makes some sense, right? So you see the customer key here, and you can see the ship date key and the due date key and the order date key, right? These are the dates where the order was made, when it's due, and when it was shipped, okay? Great. And to which customer. And you can also see over here the product. Which product did they buy? Now, what we care about for this particular video is a few things. One is sales order number. Now, the first thing you'll notice here is that this sales order number is duplicated, which is interesting. When you look over here at the sales order line number, you start to understand why. This right here is a common design pattern that you see in databases, where this idea is that a sales order is actually kind of a container, and a container for sales order line items or sale order line numbers. So for example, I can make a sales order and I can buy 4 different products, which is what you see here, 1 through 4. And you can see over here 4 different product keys. This design allows me to then say, look, I can represent in one table the complexity that a sales order can have one to many sales order lines. That means that I can buy more than one product in a single sales order. And that's good, right? That's a flexible database design. Now, for our purposes, it makes things a little bit more complicated because what we need to know essentially is, one, how recent was a purchase made? 2, how frequently does a customer make purchases? That is, how many individual sales orders does a customer make? And then lastly, how much do they spend? So right here, this design, while extremely useful, isn't great for our purposes. Now, one thing I should note, we haven't covered date logic yet in SQL, working with dates. So in this particular analysis, we're not going to do the R. In a subsequent tutorial video, we will pick up the R. So right now what we're going to do is a quote unquote FM analysis because we don't know how to do date logic yet. Once we learn how to do date logic, we'll circle back around and we'll complete this analysis by calculating the R. So today, just the F, the frequency, and M, the monetary. That's all we're going to be able to do. So what we need to do is we need to aggregate. Right? We need to collapse these 4 records here into one single record for this single sales order number, and we actually need to calculate how much was actually spent. How much was actually spent for the whole order, right? Because you can see here it's divvied out around 4 line items. Okay, well, we know how to do that. We know how to do group by, and we know how to do sums using the aggregation functions in SQL, so let's go ahead and do that. Not surprisingly, we're going to need to work with the results of that aggregation. So we're going to use a CTE, because what a CTE does, if you remember from the last video, it allows us to run a query, it allows us to run an inner query, and then it allows us to actually use that inner query, that virtual table that's produced by that inner query, in the outer query. Okay, so let's go ahead and just run this and see what happens. So now you can see here we have single sales orders for everybody. Single sales orders for everybody, and that's great. So let's see here. What was that number again? It was 19766. So let's scroll down here to 19766. 19766. Boom. And you can see here we have just a single entry for them right here for that sales order number, which is great because instead of it being multiple lines, it is now a single line. Awesome sauce. So that's the first step. Right, now if we go back at the original data and look at it again, we can say, okay, well, that's cool. We've now consolidated individual sales order line items into a single sales order number with an aggregate cost and aggregate price for that sales order. But what we also need to do is say, look, you know what, if a customer actually has more than one individual sales order, we need to collapse that down too, because we want to know 2 things. We want to know how many orders they make, how many individual orders they make, and then the total amount of dollars that the customer has spent all up. So what we need to do is we need to do a group of groups. This is one grouping here, right? We collapse these 4 line items down into one sales order, but then we need to collapse all the sales order information down to a single customer key. That's what we need to do. And we can do that next, pretty easy. Because we've got a CTE, right? CTEs are awesome. We can use the CTE, right? Here's my customer sales order CTE, and I can even just run this inside real quick. And we say, oh yeah, cool, that's what we saw before. But now that we've given that inner query, the virtual table that results from that inner query, a name, we can use it in the outer query, right? We can call it CSO, we can give it an alias, and I can do all kinds of interesting things. I can group by the customer key. And then once I've got the customer key grouping, I can say, okay, how many individual orders did they make? And how much did they spend total? So let's go ahead and run that. And then scroll down again and see customer 19766 here. Here we go. Okay. So customer 19766 made a total of 2 orders and a gross sales amount of $4,167.23. Awesome. Okay. This is the frequency and this is the sales amount. Now notice that I'm implicitly doing an RFM analysis here over the AdventureWorks data across time and space for all time. And as I said earlier, in the real world, you typically don't do all time RFM analyses very often. Usually you've got some sort of time frame. Last quarter, last 6 months, the last year. But I'm doing it for all time here just to keep things simple. So now we've got the interesting F and M information for each of our customers. This is awesome. Next up, we need to talk a little bit more about CTEs. So SQL loves us. The designers of SQL love us as analytics professionals, as people that want to work with data to drive business outcomes. And they said, look, you know what? If one CTE is good, multiple CTEs are even better. So you can actually write queries that use multiple CTEs at the same time. Now here's some more of my poor man's pseudocode. We saw this in the last video. And what this does is this shows you how you can chain CTEs together. You start with a with, and that creates the first CTE, the first inner query. Now, if you want another one, all you do is add a comma and then specify the new CTE name, CTE number 2 in this case, and you just use as again, and then you can specify yet another inner query. So this is now 2 inner queries. 2 named virtual tables will be produced by this SQL. And you can go up to X. You can do this with 4 tables, 5 tables, whatever you want to do, right? As many virtual tables as you want to create with your CTE, you can do it. In fact, I don't even know what the upper limit is, but I've never ran into it. So for all practical purposes, you can create as many of these named virtual tables in your CTE as you would like. And then the great thing is, eventually when you get to your outer query, you can use all of them. You can use them all by name, and it's awesome. So you can do all kinds of cool things. So we're going to go ahead and take advantage now of this multiple CTE capability in SQL with the next version of our query. So what we're going to do is we're going to rewrite the last query using multiple CTEs, because this will be helpful for our final version of the query. And what you can see here is if I run this, we get exactly the same output as we did in the last query run. But notice though that now I've got 2 CTEs. So this one produces a virtual table named customer sales order history. And we have another virtual table here called customer sales orders. Now, this is really cool, right? This does our first level of grouping, creates a virtual table. We've got a name for it, so we can play around with it. This second CTE actually uses the first CTE and then does a grouping of the grouping, right? Because we group by the customer key now, and we produce this. Now notice this though. Now that I've got the code written this way, I can run this one by itself. No problem. But notice I can't run this one by myself, and this should make some sense. Because SQL's like, dude, I don't know what customer sales order is. I don't know what this is. Because now we've encapsulated this as 2 separate inner queries. So we're now set up excellently to actually conduct the RFM analysis. So here is the query that actually does the RFM analysis. Now it's using a brand new window function we haven't seen before called endtile. That's this right here. Okay, let's go ahead and do some handy dandy Googling real quick. Endtile. Here is the Microsoft documentation for the endtile window function, and it explains how it works. Essentially what it does is it stack ranks things as we just described in the PowerPoint slides that we saw at the beginning of the video. By using upper bound of 10, I'm saying, look, based on my sort ordering of my window, the highest thing will get a 10 and the lowest thing will get a 1. And you can see that because it's defined by my order by clause here. Notice that we're not declaring a window. Notice there's no partition by here. We're just saying, look, run endtile over all of the data. There are no sub-windows within the data. It's all just one big window, essentially. But order by this in ascending order, and then use a maximum value of 10 and a minimum value of 1 to give me a score. Because the low stuff will get a 1 and the high stuff will get a 10. And endtile will say, okay, cool. What I'll do is I will look through all of the rows and I will determine the cutoffs. What values get 1? What values get a 2? What values get a 3? So on and so forth, all the way up to 10. So we can go ahead and run this real quick, and you can see the output here. 10, 10, 10, 10, 9, 4, 1, 8, 2, 8, 7, 7, 1, 8, 6, 7. This is the power of a RFM analysis, because you get all these different combinations of values. You have different ways of characterizing your customers. Now, obviously, the best customers are going to be 1010s. Now, remember, we're not doing an R here because we don't know how to do date logic yet. That'll be coming up soon. And you can see this customer, they spent a lot of money, but they maybe only bought once. But they bought a pretty big order, but they only bought it once. So they're not really as good a customer necessarily as like this one here, that buy more frequently and also have bought quite a bit total. because you can work a lot more with customers that buy frequently than you can with customers that only buy once, because maybe they bought everything they needed and they're good to go for a while. Whereas a customer that buys more frequently, that might be indicative of that you could sell more to them. So here we have a really cool FM analysis, and you can see by customer key here. Now, as we saw in the last video, maybe I don't care about all of the individual scores. Maybe I'm just interested in finding out what my tippy top customers are, the 1010s. Well, guess what? We can go ahead and do that using a multi-CTE query. What I do is I just wrap up the last bit of the outer query from the previous SQL that we saw as a new CTE. And great, now I can reference it and I can say, look, I just want my best customers, the creme de la creme, the tippy top. So we do this and run it. You can see here now that I only get back 966 rows. So of all of my customers, only 966 are the creme de la creme, where they are 10 and 10. Now, of course, you can do all kinds of variations of this, right? All you do is I'm having a really hard time here. There we go. You can change the where logic here, and you can say, well, maybe I want 10s and 9s and 10s and 9s. Or essentially, you could do something like this, where you can say greater than or equal to 8 and greater than or equal to 8. Because you say, well, 10, that's too stringent. 966 is not enough people, because maybe you want to mail out a circular or something like that. So you can say, okay, you know what, anybody that's 8 and above in both things is good. Now that bumps you up to 3,500 good customers that you can contact. RFM analysis. We're cooking with gas now, people. This is great stuff. You can do these analyses directly in the database. It won't be long before we'll cover date logic. We'll add the R to it, and then you'll be off and running. There you have it. I hope you're enjoying the series. If you like the content, please subscribe to the channel. And until next time, stay healthy, and I wish you very happy data sleuthing.